Walk into a Viking longhouse reconstruction, or, step inside a surviving timber structure, and one thing becomes clear. Those roofs didn't leak, the timbers didn't rot, and the interiors stayed surprisingly dry, even through harsh storms that would quickly damage modern construction. The secret wasn't thicker wood, better sealants, or even faster construction. It was one simple roof vent detail, repeated across centuries, that allowed airflow to protect structural timber. Today, we're uncovering this overlooked feature, why it worked, and how modern builders can apply the same logic to keep wood dry and long-lasting. Before we dive in, subscribe to the channel, because this is building intelligence you won't find in standard construction manuals. The Vikings understood that wood and moisture are natural adversaries. Timber absorbs water when exposed, but decay only becomes a problem when moisture lingers. Modern roofs often attempt to block water entirely, using membranes, sealants and insulation to trap moisture inside. Vikings took a different approach. They expected rain to hit the roof. What they refused to allow was stagnation. Timber had to dry quickly, and, well, the vent detail made that possible. The principle of the vent was simple: continuous airflow along the roof cavity. In practice, this meant the eaves were open or, partially open, allowing air to enter, while the ridge of the roof featured a small gap or vent where air could escape. Moisture-laden air rising from inside the structure, combined with moisture absorbed by timbers from rain, was carried out before it could accumulate. This constant movement prevented condensation, reduced fungal growth, and kept beams structurally sound. Modern builders rarely incorporate passive venting to this degree. Our insulation and sealing practices trap moisture, creating conditions where rot thrives. Another key aspect was placement. The Vikings didn't vent randomly. They targeted high-stress areas. The ridge and the junctions of major beams were priority points. Water tends to pool where timbers intersect or where structural weight compresses wood. By venting these specific areas, the Vikings created channels for airflow that kept vulnerable spots dry. Today, adding ventilation points only at gable ends or relying on soffit vents is insufficient. Targeted airflow along timber lines can prevent moisture from collecting at the points where rot begins. Timber preparation complemented this venting system. Vikings selected slow-grown pine, spruce or oak, often felled during the dormant winter season when sap was minimal. Low-sap timber absorbs less water and is naturally resistant to decay. They also seasoned beams for months, sometimes years, before installation. This ensured internal moisture was minimized from the start. Combining seasoned timber with passive airflow made roofs remarkably resilient, even in prolonged rain or snow. Modern timber is, often fast-grown, kiln-dried quickly and installed immediately, which, leaves it vulnerable to stress cracks and moisture absorption. Surface treatment was another subtle yet crucial element. Vikings didn't rely on impermeable coatings. Instead, they used pine tar, light charring, or oil-based coatings on exposed timbers. These methods repelled water without blocking vapour escape. When combined with the vent detail, rainwater quickly ran off surfaces, while trapped moisture was expelled naturally. Modern chemical coatings may initially repel water, but once breached, they trap moisture inside and accelerate decay. Understanding this balance between protection and breathability is vital for long-lasting construction. The design of roof pitch also reinforced the vent's effectiveness. Viking roofs were steep, often over 45 degrees, shedding snow and rain before it could penetrate deep into timber layers. Shallow roofs would collect snow and rain at the surface, slowing evaporation and creating chronic damp conditions. By integrating the vent at the ridge and ensuring unobstructed eaves, airflow naturally complemented the steep angle, keeping timber dry even during storms. For modern applications, increasing pitch where possible and ensuring vent continuity along the ridgeline can, dramatically reduce moisture retention. Applying this knowledge today doesn't require rebuilding like a Viking longhouse. You can simply start by creating passive airflow along timber members. Ensure ridge vents are open and continuous. Keep eaves or soffit vents unobstructed and, avoid tightly sealing timber that needs to breathe. Well, it's always best to use seasoned or slow-grown wood for structural beams when possible, and consider breathable protective coatings instead of plastic sealants. Even in repairs, adding vent channels along critical beams can, really help prevent localized rot before it even starts. The brilliance of this vent detail, honestly, is its simplicity. No complex machinery, no synthetic materials, just physics, biology and, a bit of careful observation. The Vikings mastered a principle that, honestly, modern construction often overlooks. Keeping timber dry is really more about airflow than it is about waterproofing. The longevity of their roofs, surviving through centuries of storms, snow and wind, it proves that when designed intelligently, timber doesn't actually rot on its own. If this guide gave you a new perspective on roof ventilation and timber preservation, do consider subscribing to the channel and perhaps share this episode with someone struggling with rotting beams. Relic logic exists to uncover building strategies that worked for centuries before chemicals and membranes, teaching us that quite often the oldest solutions remain the most effective.